Guys, welcome to the shop. So today's video is kind of an exciting one. I got a new vise for my milling machine. This is a Glacern Machine Tools. It's their 5-inch vise. It had free shipping over $500 at the time of purchase. So what I did is I bought a t-shirt with it and got free shipping because I was looking hard at the Schar's 5-inch vise at the same time, and really with the free shipping on this vise, they're so close in price. I just said, you know what, screw it, buying this one. I think it was maybe $50 more. So there's the t-shirt. I'll probably wear this in a video at some point. Now it's got a pretty cool catalog and folder. You know, I like it. I always could use folders. And stickers are appreciated. That'll go on a toolbox. And this, I think, I didn't know it was going to come with this, but this is really nice to have as a parts breakdown. So if something wears out or breaks and for whatever reason I don't want to make it, it's really nice to have that, so I have exactly what it's called and how to find it. So it's pretty exciting. You can see here, yeah, my total $508.99. Really not a bad price. You know, Kurt doesn't make a 5-inch vise, so that's why I went this route, because I was looking pretty hard at buying a Kurt 6-inch vise, but what I realized is a 6-inch vise is just a little bit big for me and the work I do. I think a 5-inch vise is the right size. Oh. Now, so this is really a nice feature. They're labeled with your bed height. So this is 2.5 inches and what is that? Yeah, it's 2/10. So, you know, that level of inspection, that's pretty dang good. I think what we could do later on, not today, is go look at this and compare it and see what we think it really is on my surface plate. Because, you know, perpendicularity within 0.5 thousandths and parallelism within 0.5 thousandths, that's pretty good. It's not perfect, but it's pretty good. And I think for milling machine work, that is sufficient. And one of the things to remember, guys, is sufficient is really all you need. If you try chasing perfection, you're just going to stress yourself out. Now, this is a milling machine vise where I work to, you know, within 1/1000th of an inch or two. So I don't think I'm really going to use this, but this is a 3/4 inch closer. You know, I'll probably use that for rapid adjustments, but I have a 3/4 inch wrench I keep on the mill anyway for my drawbar. So I don't think I need that. But, you know, you never know. Now that I've said that, I probably will. But what we're getting at here is I'm pretty pleased. It's well packaged. There's no damage to the packaging. And you can see this is still not a dainty piece of cast iron. It's about 45 pounds. And so I think this might be what's called a vapor corrosion inhibitor bag, VCI. You see these gun collectors will use bags like this because they release a chemical over time that helps inhibit corrosion on top of the oil and grease. Now, I don't know that for sure because really it might not be. They might have just counted on the heavy oil or wax to be an effective corrosion inhibitor. But this also could be a VCI bag. I just don't know for sure. On visual inspection, I am impressed with the surface finish. I think it's very good. I wouldn't really expect anything less from a US-based manufacturer, and that also is one of the selling points, is that this is a US-based manufacturer. I'm an American small business. I want to support the Americans, especially when they're really close in price to the imports. Now, one thing I've seen here is the lead screw has a lot of grease on it. I'm not 100% sure looking at it because it is kind of hard to see through the grease whether or not this is Acme threads. One of the things that stuck out to me on the, God, I'm drawing a blank, the Shars Vise, is that it isn't Acme threads. They are, I believe they're buttress threads, which is sufficiently strong, but they're going to wear sooner. So I'm just going to open this up all the way and see how far it opens. Manufacturer claims I think it's 5 inches, but looking at it, I think we're quite a bit more than 5. So I'm just going to grab a 6-inch rule. Oh yeah, we're exactly 5 inches here on my rule. So yeah, I think that's plenty. My 6-inch Bridgeport vise, which we're going to put this next to, only opens up to 5 3/4, and I haven't really run into the limit in that regard. I don't think that the vise opening distance is really going to be a deal breaker for me, at least. Now I'm going to try it with keys, and we'll see if it trams with the keys on. It might be, it might not be. Their inspection report said it should be pretty close, so. Of course, it's a 3/16 key that I need, so excuse me while I wander off camera. Oh, I have 3/16 right here. Yep, 3/16. That's really common, so I think these are 1/4-20. Just looking at them, I'm not looking that hard. Almost everyone using a 1/4-20 bolt or screw, in this case, they're always 3/16. Now, I like keys because I'm lazy and don't like tramming vices when I don't have to. But the advantage to not using keys is you can actually tram a little bit more precisely than you can with keys. So it really depends. Like I said, I don't do super high precision vise work all that often. So for me, a vise being like a 1/2 thousandths or 1,000th set of square is largely irrelevant. So for me, again, it's not really a big deal breaker. I do see a little bit of corrosion on the hex, but it's a vise, guys. It's not going to be perfect for long, and given that this is a brand new vise, I'm probably going to Stevie Wonder my way into it with a face melt, so, you know, not going to worry about that. I'm just over here. I took one of the chip covers off my mill, and we're going to set it on the machine side by side with my old vise, which I believe is actually original to the machine. Okay, so this is one cool feature. I didn't actually notice this originally, but there's a nice handhold right here to pick the vise up. That's not solid. Now, this is a trade-off in rigidity, so something to bear in mind with this is not an integral fixed jaw. The Bridgeport is an integral fixed jaw. So, you know, we've got, actually, interestingly enough, this vise sticks farther over the back of the machine than my Bridgeport does. So this may actually stick out farther than my stop I have on the back for the digital readout reader. And also the bed height on this is a little bit higher than it is on my Bridgeport. It looks like probably by about 3/8 or 1/2 inch. Yeah, it looks like about 1/2 inch from the end. This is 1/2 inch. Also about 3/8. Just eyeballing it. Now, but you'll also see the working area really isn't all that much different in how far the jaws open. So let me grab a scale. So these aren't rulers, they're scales or rules. Depends who you ask. I don't worry about it too much. So the Bridgeport jaws also only open 5 inches. So if I'm not working in just doing heavy cuts, I actually do not have any trade-offs in working space with the functional working space with this vise than I do with my Bridgeport. Now the only downside is the Bridgeport does sit a little bit lower than the angle lock vise because the screw's up top, it's not down low, so you do need to have clearance built into the body of the vise for the angle lock mechanism. Basically, so the angle lock mechanism interfaces, so we'll pretend this is the cup in that movable jaw, but it puts force not just this way into the movable jaw, but it pulls it down. So that's why this is kind of a curt clone where it's called an angle lock vise, because, let me grab the diagram. Diagram explains this better than words. See, you've got this dingus here that interfaces with a ball and cup recess inside the movable jaw to pull it down. It sort of works a little bit like a toolmaker's vise, where a toolmaker's vise just has a screw right here. See, like this guy is the toolmaker's or grinding vise, where you see that this screw runs at an angle. The downside to this is that you have to knock this pin out to make real rough adjustments on the vise. And as you see, it can be a little bit fiddly, especially when you're on camera. I usually don't have that much trouble getting it in, but performance anxiety. So you see this is a little bit more fiddly. You don't have the same range of adjustments, but this is accurate to within 2/10,000ths of an inch. This is accurate to within 5/10,000ths of an inch. This doesn't have quite the same clamping power and trade-offs. So again, these are all trade-offs. Like, they're different tools for different jobs. Now the Bridgeport I'm going to keep around because I have a swivel base for it. So the swivel base, if I'm going to cut an angle, honestly, that can be really fast and easy to just set up. I'll bolt this to the swivel base and it'll be permanently integrated that way. So what we're getting at here is just because it's a vise and just because it's a machinist's vise or a milling machine vise doesn't mean they're all exactly functionally interchangeable. They do have different advantages. Now, without bolting this down, I'm really keen to check how well trammed it is. I think we're going to use, what do we want to use, guys? I'm just going to use my 1/2,000ths indicator because it's already in my hand. And we're going to try, can you read that? We're going to go lower the camera down until I can read the dial on camera. Bring it forwards. Yeah, this is a little tricky. It's not going to be perfect. Also, it's a good idea for maximum precision on your probes for DTI to have them as perpendicular as you can to the work. So there we are, we set 0. There's no trickery. This is just as it is. So we're actually off by a lot. Now let's see. Oh, we have enough slop in here that I can correct tram. Let's set 0. Again. Close enough. All right, so that's 1/2 of 1/1000th of an inch off. Good enough. Now another thing we can do is set 0 again. It'll fart with it. Now let's just raise the knee up and down. I guess we're gonna have to put the indicator sideways and twist it around. That'll work. So there's going to be cosine error in this, just by the nature of how I have the angles set up. So don't treat this as best practice, guys. What we're just looking for here is how much the needle moves as I lower the table down and sweep up. Taking up the backlash. So it jumped about 1/1000th very quickly. Let's set 0 again, because I think I did something wrong. So 0 at the top. And there, well, you know what, we're getting... So I think what we're actually getting here, guys, is what's called knee rock, where we're hitting a really worn section of the knee ways. And you can see the indicators moving in and out as I lock that gib. So this is actually a pretty good example of wear on a milling machine. So you see we're also getting what's called stick slip, where I'm cranking the handle and I feel it, but it's sticking. And that's because this machine's pretty worn. And we're also at pretty much the extreme limit of the Y. So I think I'm gonna have to pull the ram back towards the rear of the machine, i.e. retract the ram and push it that way, so I can take full advantage of this vise, because what you can see here is my drill chuck is more or less centered over the middle of the fixed jaw. Now, another reason to get a 5-inch vise is I have a 9-inch knee. So this machine, this only moves about 9 inches, not the full 12 inches of the later machines. So I have a little bit less Y travel than a later J head. But the benefit of that is I do have a slightly more compact machine. So thanks for watching, guys. I hope you're still awake, and if you are still awake and appreciate this style of content, just, you know, give me a subscribe or give me a comment, you know, any feedback on what you like and what you want to see more of.